Welcome to the DIY Honda Garage channel. In this presentation, we will delve into the details of Diagnostic Trouble Code P0703, associated with the brake pedal position switch malfunction for the Honda HRV model years 2016 to 2022. Understanding this specific DTC is crucial for effective troubleshooting. The brake pedal position switch, or BKSWNC, is responsible for signaling the position of the brake pedal to the vehicle systems, particularly impacting the operation of cruise control and other safety features. The location of this switch is typically found near the brake pedal assembly inside the vehicle's interior, making access important for diagnosis. When this switch fails, it can lead to various issues, including improper vehicle behavior and triggering error codes such as P0703. This presentation aims to provide a systematic troubleshooting approach to identify and resolve the underlying issues related to this DTC. The brake pedal position switch, designated as BKSWNC in the diagnostic system, plays a critical role in the vehicle's safety and operational systems. This switch detects the angle or position of the brake pedal when pressed and relays this information to other systems, which may include the cruise control module and the engine control unit. If the switch fails or sends erroneous signals, it can deactivate cruise control or cause other malfunctions. This component is typically mounted within the vehicle's interior, near the brake pedal assembly for easy access. It's crucial to ensure that this switch is functioning correctly to maintain vehicle safety and performance. Typically, the first indication of malfunction occurs when the vehicle's onboard diagnostics note a discrepancy in signals, leading to the storage of DTC P0703. Several possible causes contribute to the DTC P0703 error code. A primary suspect is a faulty brake pedal position switch itself, which may fail to operate correctly or produce incorrect signals. Additionally, wiring issues related to the BKSWNC line can also lead to signaling errors, as damaged or corroded connections may impact communication between the switch and the vehicle's electrical system. Furthermore, problems with the IG1 ACG or the HRV line, which connects to power components, can also cause issues. These wiring faults may result from environmental factors such as exposure to moisture or heat, leading to deterioration. Understanding these causes is vital for accurately diagnosing the issue and implementing effective repairs. The symptoms associated with the DTC P0703 can manifest in several noticeable ways. One of the most common indicators is a malfunctioning cruise control system, which may fail to engage or disengage properly. In addition to issues with cruise control, drivers may experience erratic behavior with the brake system itself, leading to uncertainty during operation. This erratic behavior can also trigger warning lights on the dashboard, alerting the driver to a potential malfunction in the brake system. Furthermore, the vehicle may exhibit behaviors of failing to respond when the brake pedal is pressed, leading to increased safety risks. Recognizing these symptoms early can aid in diagnosis and repair before they escalate into more serious problems. To begin troubleshooting for DTC P0703, the first step involves turning the vehicle to the on mode without pressing the brake pedal. Utilizing the Honda Diagnostic System, or HDS, check the signals generated by the brake pedal position switch to determine their current condition. You will look particularly at the cruise brake SW and stop SW signals to assess their values against predetermined thresholds. If the current conditions match the expected thresholds, you can move on to Step 7 for further analysis. However, if there is a discrepancy, indicating that the signals do not align with the threshold values, proceed to the next troubleshooting step, to further examine the installation of the brake pedal position switch. The second troubleshooting step entails verifying the installation of the brake pedal position switch. Start by turning the vehicle to the off mode, ensuring safety is prioritized. Next, adjust the brake pedal and position switch for proper alignment. Once adjusted, turn the vehicle back to the on mode, but refrain from pressing the brake pedal. Check the same signals again using the HDS, looking closely at the cruise brake SW and stop SW parameters to ensure they now match the threshold values. If they do, it suggests that the failure might not be a persistent issue, allowing you to document this and move forward. If the conditions still do not match, proceed to the next step to determine the area of failure. During the third troubleshooting step, you will assess all possible failure areas relating to the brake pedal position switch. Start by turning the vehicle to the off mode. Disconnect the 4P connector from the brake pedal position switch, which is crucial for isolating the system. Then, using a jumper wire, connect terminals A and B at the brake pedal position switch connector. With this setup in place, turn the vehicle to the on mode again. At this point, check the signals via the HDS for the cruise brake SW and stop SW while monitoring the threshold and current values. If these values now correspond before proceeding, it indicates that the brake pedal position switch may require replacement. If they do not match, continue to the next troubleshooting step. In the fourth step, the focus shifts to evaluating the integrity of the IG1 ACG/HEV line. Turn the vehicle to the off, lock mode first. Afterward, remove the jumper wire previously connected to the brake pedal position switch. Once the jumper wire has been removed, turn the vehicle to the on mode and measure voltage between the defined test points on the 4P connector. For correct testing, ensure the brake pedal position switch is disconnected while establishing these measurements. If you find that there is battery voltage, it confirms that the IG1 ACG/HEV wire is functioning as expected. If not, further steps need to be taken as there may be an underlying wiring issue needing repair. Fifth step involves conducting an open wire check on the BKSWNC line. First, turn the vehicle to the off lock mode and jump the SCS line using the HDS, waiting more than 1 minute to ensure proper system integration. Disconnect the PCM connector A, 51P, to allow for proper testing. After the connector has been disconnected, use a jumper wire again to connect terminals A and B as specified in previous steps. With these connections in place, turn the vehicle to on mode once more and measure the voltage at PCM connector A, while ensuring that the BKSWNC line is jumped and the 4P connector is disconnected. If battery voltage is present, it indicates the wire is functional, and you may have to explore authorized service data related to the DTC or test a known good PCM. If not, there may be an open circuit in the wire that requires repair. Step 6 focuses on checking the status of fuse number C30, as fuse failures can often lead to larger issues in the vehicle's electrical system. Begin by turning the vehicle to the off lock mode, ensuring you are following safety protocols during this diagnostic stage. Check the specific fuse number C30 to confirm its status, whether it is intact or blown. Should the fuse be in good condition, you may have to follow through with repairs on the IG1 ACG/HEV line, which may have sustained damage from previous conditions. If the fuse is indeed blown, replace the number C30 fuse and check if there are any shorts to ground within its circuit, which can often lead to such issues. Thoroughly investigating this fuse is vital to ensuring the integrity of the vehicle's braking and electrical systems. In troubleshooting step 7, we revisit the brake pedal position switch signal analysis. Start by turning the vehicle to the on mode. Once activated, gently press the brake pedal and check the corresponding signals using the HDS again, particularly for the cruise brake SW and stop SW parameters. Ensure that you are concurrently monitoring the threshold conditions against the actual values being reported. If they match, it might indicate an intermittent failure where the system could be functioning under certain conditions, warranting further investigation into potential connection issues or loose terminals connecting the switch and the PCM. If discrepancies remain, continue to step 8 for a closer examination of the brake pedal position switch itself. The final troubleshooting step focuses on the brake pedal position switch testing. Here, you will perform direct tests on the brake pedal position switch to evaluate its operational status. If this testing confirms that the brake pedal switch is indeed functioning correctly, it suggests that the issue may lie elsewhere, potentially indicating a short circuit in the BKSWNC wire between PCM A25 and the switch. Conversely, if the test results show that the switch itself is faulty, it will need replacement to rectify the DTC P0703 issue. This switch is vital for proper signal transmission throughout the vehicle, and its failure can lead to several cascading issues concerning vehicle operation and safety. After implementing the necessary repairs regarding DTC P0703, it is crucial to fulfill the final verification stage. Start by verifying that DTC P0703 has been cleared from the vehicle system using the HDS. This is the first step in confirming that any potential issues have been successfully resolved. Following this, conduct a test drive to ensure the vehicle operates correctly and that the brake pedal position switch is now functioning as intended. During the test drive, pay particular attention to brake responsiveness and cruise control functionality, observing for any signs of return of prior symptoms. Ensuring that all related systems are operational without any new fault codes present is vital for confirming comprehensive repair success. Preventive maintenance plays a key role in avoiding the recurrence of issues like DTC P0703 in the future. Regularly inspect the brake pedal position switch for signs of wear, rust, or physical damage, as environmental factors can contribute to deterioration. Moreover, routinely check the condition of the associated wiring to ensure there are no frays, corrosion, or breaks that could disrupt signal integrity. Battery health is also vital, as consistent electrical supply can mitigate the occurrence of multiple faults. Lastly, promote good habits like careful operation of the vehicle's controls, which is also important in minimizing stress on these components and prolonging their operability. In conclusion, addressing DTC P0703 effectively involves understanding its symptoms, possible causes, and a structured troubleshooting approach. As we navigate through each diagnostic step, from signal checks to component testing, it becomes clear how vital proper operation of the brake pedal position switch is to ensuring safety and functionality in the Honda HRV. By following these diagnostic steps, repairs can be accurately targeted, leading to successful resolutions of the issues at hand. Ultimately, to avoid encountering similar problems in the future, routine maintenance checks and timely inspections are essential. A proactive approach ensures that vehicle performance remains optimal and driver safety is prioritized. Please like and subscribe to the channel. See you next time.